The mixed model does different things, but one thing is it allows for several sources of variation. So you might have variation between animals and within animals, as we might do with our crabs. If you were analysing a study where there were different centres or farms, then there would be variability between the centres or farms and within them. And so you can build that into the model. You can sort of partition your variation, your random variation. And you would do that by adding what are called random effects into the model. So you would add random effects for something like animal or centre, depending on where your sources of variation were. Another useful thing mixed models can do is allow for correlation in the data, correlation structure. So for our repeated measurements, we could say, yes, well, we think they're going to be correlated on the same animal. But it's possible that animals with values, if the values are closer together in time, there's going to be more correlation than if they're widely separated in time. So you can put some structure to that correlation. So if we contrast that with general linear models, although they can fit lots of effects, they're only assuming random variation at the error level. So it's basically assuming all the observations are independent. And in those models, you might describe those effects as fixed effects to sort of differentiate them from the random effects that you can put into mixed models. Basically, general linear model, which is suitable for normal data, you've got fixed effects only, and in the mixed model you can also put in random effects to sort of partition the levels of variation in the data, and that can have several sort of desirable properties. Just a note there to say that still you've just got one outcome, it still has a pattern of one outcome and then one or more independent variables on the right hand side of the equation. So thinking about a mixed model for our repeated measures data, then this is the model that we would fit. We would include crab effects, but we would include them as what's known as a random effect. So they'd be a source of variation rather than a fixed effect, but these other time diet and the time by diet interaction, which should be a sort of an optional effect, could be fitted as fixed effects. And this model will be suitable even if there were some crabs that didn't maybe have measurements at some of the time points. It might be that there are fewer crabs at day 11 compared to day 1, and it would still be appropriate. Some package will offer repeated measures analysis of variance, but that's only really suitable if you've got complete data. So just to kind of whet your appetite for mixed models, I've just listed some of the potential advantages. So they properly take into account variability at all levels. For example, in a multi-centre trial at different centres, it allows you to say treatment of variable between the centres. You can incorporate that into the model. In repeated measures trials, what comes out is treatments. If you're measuring treatment, it's going to be appropriately compared to the between patient or between animal variation rather than comparing across the measurements in the same animal and treating the data as sort of erroneously independent. If you've got unbalanced data or missing data, that won't cause a problem, although of course it is quite important that you can assume the missing data are missing at random, so that's something else to think about. You can, in some situations, actually get more accurate estimates. It kind of can recover more information, particularly in the situations where there's missing data, so that's another advantage.